Hello, welcome to Unacademy YouTube channel. All the viewers, myself Vetrivel, Unacademy Physics Educator. Today we are going to discuss important concept of surface tension. First, I welcome all the viewers for Unacademy Plus course. It is the best online platform for the aspirant, those who are preparing for KCET 2021. So, subscribe Unacademy Plus course, non-stop competitive exam for all the PCMB subject you can learn. It will be very useful for your KCET 2021. So, use my code Vetrivel Live to subscribe Unacademy Plus course. Today, let us discuss surface tension. As we all know, surface tension, it is the property of the liquid which its free surface behave like a stretched membrane. You all might have seen on the surface of water, the mosquitoes and other insects can able to walk on the surface. The surface of the liquid behaves like a stretched membrane, like a balloon. If you stretch it, how it will be. Similarly, the surface will behave like a stretched membrane so that the insect others can able to walk on the surface. We know that surface tension denoted by letter T, this is the tangential force acting per unit length. So surface tension does not obey Hooke's law. We know that Hooke's law, within the elastic limit, stress is directly proportional to strain. So surface tension, force acting per unit area, force Newton per meter, SI unit. So the property of the liquid by due to which the free surface behave like a stretched membrane is called surface tension, right? Now surface tension, force per unit length, right? See here, the surface of water behave like a stretched membrane. So unit Newton per meter, CGS unit Newton become dyne, meter become centimeter. So 1 Newton per meter equal 10 power 3 dyne per centimeter. So surface tension formula, keep in mind. Now dimensional formula for surface tension, ml power 0 t power minus 2, right? Surface tension is a scalar quantity. Application of force of surface tension. So these important formulas you need to remember while solving numericals. See, the force required to lift the floating bodies against force of surface tension. Suppose on the surface of water, one rod of length L is floating. Assume a sieving needle. Just you can carefully place it on the surface of water. The sieving needle can float on the surface, or one wire, right? Now if you want to lift it, means what is the force required to lift the floating bodies against the surface tension, right? So see here, a wire is floating on the surface of water, or you can say a thin rod of length L is floating on the surface of water. Now what is the force required to lift this wire against the force of surface tension? We know surface tension equal to force per unit length. Now force required to lift this wire from the surface of water against the force of surface tension is, see that F equal to T into 2L, right? We know that it's where the length of the wire is touching already the surface of water. It has two surfaces, right? That is why twice length. So formula keep in mind. The force required to lift the wire of length L from the surface of water to L into T. So in case of circular disc is floating on the surface of water. If you want to lift it, what is the force required to lift the circular disc from the surface of water? Force equal to T into circular disc. Circumference will be 2 pi r. In case of circular loop has two free surfaces. So force required to lift the circular loop from the surface of water will be T into, it has two free surface, so twice in circumference 2 pi r. A square plate, suppose a square plate of side A is floating on the surface of water. A square plate having side A is floating on the surface of water. What is the force required to lift this square plate against the force of surface tension? That is, we know force required equals surface tension into, we know that square plate has a 4 side, so 4 into side, right? Similarly, a square loop in the sense it has free surface area, 2 surface area. That means, see that already circular disc 2 pi r, circular loop it has 2 free surface, so twice. Same way, square plate is only 4 into side. Square loop in the sense it has 2 free surfaces, so twice you need to multiply. Rectangular plate it will be force required to lift one rectangular shape of the wire which is placed on the surface of water. Surface tension T into twice length plus breadth. So these formulas, remember, it will be very useful for numerical, right? Now, a wire PQ of length 5 centimeter, see that, a wire length PQ 5 centimeter which is free to move and fro. That PQ can be moved either left and right freely, we can move, movable one, PQ. A rectangular frame ABCD, in that a PQ length wire can free to move on either side to and fro. When this frame is dipped in a soap solution, after dipping in soap solution you raise it. The force F required to keep the wire PQ in equilibrium, right? After dipping in the soap solution you just raise it, and then how much force is required to keep the PQ remains in equilibrium, again the same position, right? Here what is given, length of the PQ is given 5 centimeter, that is 5 into 10 power minus 2 meter, convert centimeter into meter. Surface tension already given in the within the bracket. Surface tension is given 4 into 10 power minus 2 Newton per meter. Here, what is the force required to keep PQ in equilibrium? Originally PQ can movable to and fro either side, right? Now when it is dipped in a soap solution, when try to lift it, what is the force required to keep the length 5 centimeter PQ wire in its original position, equilibrium position? So force required, we know that formula, force required equal, we all know surface tension T equal to F by L. From that F equal surface tension into, whenever it is dipped in a soap solution it has 2 surfaces, right? 2 free surfaces, right? So it will be twice L. So tension, surface tension is given 4 into 10 power minus 2 into 2 into length. PQ length is 5 into 10 power minus 2. Right? Multiply, you will get, right? See that 2, 5, 10, 10 fours, 40 into 10 power minus 4 Newton. That will be 4 into 10 power minus 3 Newton. This is the force required to keep the PQ wire in its equilibrium position. Here why we multiply 2 mean the soap solution, right? Whenever we dip it there, soap solution has 2 free surface. So twice L. So this is the correct answer. We'll move to the next one. A small piece of wire 4 centimeter long. So length of the wire is given 4 centimeter. Is floating on the surface of water. If the force of 560 dyne in excess of its weight is required to pull it up from the surface, find the surface tension of water. See that a small piece of wire, 4 centimeter wire, is floating on the surface of water. A force of 560 dyne, CGS system given force 560 dyne force in excess of its weight is required to pull it up. Right? See, it is on surface of water. A 4 centimeter wire is floating. Right? So how much force is required to pull it up? The force required to pull it up this 560 dyne. Then what is the surface tension of the water? Right? So we know that the contact length of the solid with the liquid surface. Right? Here the wire, piece of wire 4 centimeter long. It is floating on the surface of water. Then what is the contact length of this wire? Right? The contact length of the wire solid, right, with liquid surface, with water surface. What is the contact length of the wire with water surface? That length is twice. It has, right, 2 free surfaces. So twice length, 2 into 4, you will get, it is 8 centimeter. The contact length of the solid with the liquid surface. Right? When it is on liquid surface, it has the 2 surfaces on either side. So 2L. Now the question is surface tension of the water. We know that surface tension T equals, right, force per length. Surface tension. That's it. Now the force per length, right, force is 560 dyne. So 560 by L is here 2L, 8 centimeter. That's it. You will get 70 dyne per centimeter. Right. Dyne per centimeter is the correct answer. So surface tension, force per unit length. You can go ahead, easily you can get. Yes, let us go for the next sum. Surface tension depends on, these are the factor. The surface of the water or the liquid behave like a stretched membrane. So the surface tension depends on nature of the liquid, temperature of the liquid, impurities, right? Medium over the liquid, charge on the liquid drop. These are the factor depends on surface tension. What is surface energy? We know surface tension T equal to F by L. What is surface energy? See that the work done to increase the surface area by 1 unit is called surface energy, denoted by, see that, surface energy, the work done to increase the surface area, increase in area delta A, right, by 1 unit, or the potential energy per unit surface area of the liquid is called surface energy. So surface energy is numerically equal to surface tension under isothermal condition. So keep in mind, surface tension T equal work done to increase its surface area. See clearly, surface tension T equal work done to increase in surface area. Work done W by increase in surface area of the liquid by 1 unit. It is surface energy. From this we can write W, that work done equals surface area into surface tension. So this is surface energy. What is the work done in blowing a liquid drop? Suppose one liquid drop we want to blow that. So if the initial radius of the liquid drop is R1, the final radius of the liquid drop is R2, right? The surface energy, see that the work done equal surface tension into increase in surface area, right? The liquid has only one free surface. So work done equal to, we know, surface tension into increase in surface area. So work done into increase in surface area, we know the shape of the drop, right? So 4 pi r square, 4 pi r square. So see that the liquid drop initial radius R1, final radius R2, that is why final minus initial, 4 pi r square. So R2 square minus R1 square, that's only here. So work done in blowing a liquid drop is surface tension into increase in area. Since it is a spherical shape, 4 pi r square. In case soap bubbles, you all will play with the soap bubbles, ring will blow it, large number of bubbles will come out. In case of soap bubbles, what is the work done in blowing? So work done equals surface tension into increase in area. See, for drop it is 4 pi r square, but soap bubble has two free surfaces, so multiply into 2. So 2 into 4 pi, 8 pi. So keep in mind, work done in blowing the liquid drop means this is work done in blowing the soap bubbles, right? It has two free surface, so 8 pi into R2 square minus R1 square. What is the work done to split a big liquid drop into identical small drop? The bigger drop, if you want to split it into large number of smaller drop, right? So see that volume remains constant. So bigger drop 4 by 3 pi r cube into, see, mass constant mean mass equal to volume into density. So volume of the bigger drop 4 by 3 pi r cube into density rho equal n number of the bigger drop divided into split into n number of smaller drop. That is why n into volume of smaller drop 4 by 3 pi r cube, right? Smaller drop radius, this is bigger drop radius into density. So 4 by 3 pi all cancel, density you will get r cube equal to this. So r equal r cube both sides, 3 we can cancel it, r equal n 1 by 3 r. Keep in mind, r small r equal, right, r by n 1 by 3 will become power minus 1. This is work done to split the bigger drop into smaller identical drop. Here work done equal surface tension into change in area, right? Surface tension into change in area. Now we can able to do this. Next, when n smaller drop, reverse it now. when n identical drop radius r, smaller drop radius, are merged, combined to form a bigger drop of radius capital R. Right. Now, what is the work done by the surface tension? Right. Work done by the surface tension is when droplet are combined to form bigger drop, n number of droplet combined to form bigger drop, surface area decreases. So work done by the surface tension. The work done by the surface tension is, we know work done equal, right, surface tension into increase in area. Right. So surface tension T into increase in area, 4 pi r square into n 1 by 3 minus 1. This is work done by the surface tension when n identical drop, smaller drop combine to form a bigger drop. It is the work done, 4 pi r square T into n 1 by 3 minus 1. Unacademy is the #1 online platform for competitive coaching. So it is the best option for all the aspirants, those who are preparing for KCET 2021. Use my code Vetrivel Live, subscribe Unacademy, and it definitely benefit for your preparation of KCET 2021. Here it is. A spherical shape of raindrop is due to surface tension. We know why raindrop are spherical in shape, right? In order to attain the minimum surface area, right, due to surface tension, that is why the raindrops forming always, right? So that we know that for a given surface area, minimum volume will be drop, spherical shape only. So in order to attain the minimum surface area, right, the raindrops become spherical in shape. It is due to surface tension. Even the mercury, you drop it on the table, you see it split into, it try to occupy smaller droplet, right? Minimum surface area. So the spherical shape is due to surface tension. Now, a thread is tied slightly loose to a wire frame. You see that this is the wire frame thread. It is a frame. A thread is tied slightly loose to a wire frame as shown in figure. It is a frame. It is a thread slightly loosely you are keeping. The frame is dipped in a soap solution and taken out. The frame is completely covered with the film, right? When the portion A, see that this portion punctured with the pin, the thread, what happened? See, when this thread is tied slightly loose to a wire frame and this frame is dipped in soap solution, it will form a bubble. Just you puncture that portion A is punctured, then this thread will move, becomes concave towards A, become convex towards A. See, concave, right, convex, right, and remains in the initial position, either A or B, depend upon the size of A with respect to B. So here the correct answer is the film. What happens? Soap film, right, it will form soap film. If you puncture that area, the film tried to cover minimum surface area. Try to cover minimum surface area means it tried to pull inside. It looked like, right, concave. It tried to pull. So what happened? It tried to pull inside. So it become concave towards A. It will go this side. Concave towards A is the right answer. First option. Reason is the film tried to cover minimum surface area. That is why it will become concave shape. It will pull inside. We'll move to the next one. Option A is correct. A thin liquid, see there, a thin liquid film formed between U shape. See that this is the U shape, this is the thin film formed, right? U-shaped wire and a light slider. See that this is slider, say PQ is the slider, can move freely. Slider support a weight of 1.5 into 10 power minus 2 Newton. The length of the slider is 30 centimeter. So the length of the slider is 30 centimeter. The slider can slide over the U-shaped wire and its weight is negligible, right? The surface tension of the liquid film is, question understand, the surface tension of liquid film, a thin liquid film formed between the U-shaped wire, right? Here a slider a weight of 1.5 into 10 power minus 2 Newton, okay, light slider supporting its weight, right? Now the length of the slider is given 30 centimeter. What is the surface tension of the fluid? We know surface tension equal, right, general formula. Here the surface tension equal force is mg. Since see that its weight, slider support a weight, so force here mg, right, by length is here, since it is, what is that, thin film is there, so twice L. It has a two free surface, so that's the formula, surface tension mg by 2L. Now mg, how much is given mg here? Mg is nothing but weight, weight equal to mg, so weight is given here 1.5 into 10 power minus 2 Newton by 2 into L. Length is here given 30 centimeter, convert into meter, 10 power minus 2. You will get, right, 1.5 by 600, that is 0.025 Newton per meter. First option is the correct one, right? Surface tension equal force is mg, force by 2L. Use the formula, you will get option 1. Let us go for the next one. Two pieces of glass plate, one upon the other, with the little water in between them, cannot be separated easily because of, you see that two glass plate, assume if the two glass plate in between some water drop is there, if you attach and then you try to separate, very difficult. The two pieces of glass plate, one on another, a little water is in between them, so it cannot be separated as easily because of, we know, surface tension. Why? The surface tension pulls the plate towards each other. How surface tension? Stretching the surface of water. Similarly, in between the two glass plate, water drop is there. So the surface tension pulls the plate towards each other. That is why it's very difficult to separate it. It is due to surface tension. Work done in splitting a drop of water 1 mm radius into 10 power 6 droplets. How much work done to split a drop of water? See, drop of water radius capital R. See, I want to know how much work done to split a drop of water. So radius of water R into n number of smaller drop radius small r. So the work done in this case equal to, we know the formula, 4 pi r square into surface tension into n 1 by 3 minus 1. We have seen this, right? The work done to split the heavier drop into smaller drop, right? So surface tension, given surface tension of water, the work done is 4 pi r square T into n power 1 by 3 minus 1. That's it. Now we can substitute 4 pi, right? What is the R? Heavier drop of water, radius 1 mm. 1 mm convert into meter. So 10 power minus 3 by 1000. So R square, 10 power minus 3 square. Surface tension is given already within the bracket, 72 into 10 power minus 3 into n. Right here 10 power 6 droplet is given. I am splitting heavier drop into 10 power 6 smaller drop. So here n is how many number? 10, but n is 1 by 3, but here is given 10 power 6. So 10 power 6 by 3 minus 1 equal 4 pi into 10 power minus 6, 2 into minus 3 into 72 into 10 power minus 3 into here what happened? 3 2s are 6, 10 square, 10 square 100 minus 1. So when we simplify this, you will get, right, 4 pi into, right, all we will get what, 10 power 6 into 72 into 10 power minus 3 into 99. That's it. Simplify, you will get 8.95 into 10 power minus 5 joule is the correct answer. Option 2 you will get. When 10 power 6 small drop coalesce, that means combine to make a larger drop, then the drop density decreases, density decreases, density increases, temperature increases, temperature decreases. Just to reverse, previous problem we did heavier drop split into smaller drop. Here 10 power 6 smaller drop, this is meaning coalesce, combine to make a larger drop. During this process what happened? Right? 10 power 6 smaller drop combine to form heavier drop. Then during this formation, what happened? When smaller drop combine to form mean energy will be liberated during this. As a result, temperature increases. Large number of smaller drop combine to form heavier drop during that time because energy is liberated. So temperature increases. A big drop of radius capital R is formed by 1000 small droplet. Right? So in this case, what is the radius of the smaller drop? So in both sides, volume remain constant. Right? So bigger drop volume 4 by 3 pi r cube equal n number of 1000. See? How many number of smaller drop? 1000 number of smaller drop. See, volume of bigger drop is equal to n number of volume of smaller drop. N is here 1000. What is the volume of smaller drop? 4 by 3 pi r cube. Right? As volume is remain constant here. Right? Volume is constant. Now 4 by 3 pi, 4 by 3 pi. We know that. So r cube equal to, right, 1000 r cube. So r equal 10 r. From this small r equal r by 10. Radius of smaller drop r by 10 is the correct option. Let us go for the next one. The surface tension of the liquid T is given 5 Newton per meter. If the thin film of the area is given formed on the loop, then what is surface energy? We know surface energy equals surface tension into increase in area. Right? So surface tension 5 into increase in area. See that the thin film, it has the 2 free surfaces. So twice, that is important. Twice into surface area 0.02. That's it. The film has 2 free surfaces, that is why 2 I multiplied. The thin film has 2 free surfaces. So multiply, you will get 2 into 10 power minus 1 joule. So C is the correct answer. Let us move to the next one. What is the ratio of surface energy of one small drop and one large drop if 1000 small drop combine to form one large drop? What is the ratio of surface energy? Here question is surface energy of one small drop to the one larger drop, right? Now in this case we know volume of the liquid remains same, volume remains same. So volume of 1000 small drop will be equal to volume of one big drop, right? Volume of 1000 small drop is equal to volume of one big drop. Then equate it n times 4 by 3 pi r cube. Volume of n times n number of volume of smaller drop is equal to volume of bigger drops. That's it. So we know that here 1000 small r cube equal to r cube. We did previous problem also same, right? So it is r cube. Understand? So from this what is r? R is, we know, 10 small r. Clear? So from this small r by capital R equal to 1 by 10. Question is the ratio of surface energy of one small drop. Ratio of surface energy. So ratio of surface energy of one small drop by one big drop. What is the surface energy of one small drop by surface energy of one big drop? That is equal to, we know surface energy of small drop is, okay, surface tension into change in area, 4 pi r square, smaller drop r. So similarly surface energy of one big drop is surface tension into 4 pi r square. Here t 4 pi everything cancel. You will get only r by r whole square. What is r by r? 1 by 10 whole square. So you will get 1 by 100. So 1 is to 100. Surface energy of one small drop to the surface energy of one bigger drop, right? So that's the end of today's session. I hope you learned a simple basic concept of surface tension and surface energy. This concept will be very useful for your competitive examination. This is a symbol like a small drop I showed you, right? Once you join, subscribe Unacademy, there you can see that continuous class of surface tension, right, for unlimited n number of problem with different technique you can able to watch in Unacademy Plus course. So all the viewers use my code Vetrivel live to subscribe Unacademy. You will get additional 10% discount. So with that, myself Vetrivel, Unacademy Unacademy Plus educator, signing off from you all. Have a nice day. Thank you.